You know that feeling when you look up at a really clear night sky and just wonder? All that light from all those stars, it's traveled for millions, sometimes billions of years just to reach your eyes. But what if we could follow that light backwards? What if we could trace the path of every single thing in the universe back to its source?
Well, that's exactly what we're going to do today. Think of it like the ultimate cosmic detective story. We're going to follow the clues, rewind the clock for the entire universe, and find out exactly where all these paths lead.
All right, let's get into it. The very first clue, and honestly, it's the biggest one, is that all of those paths, every single one of them, they all converge. They meet at one single, solitary point in spacetime, an event that we call the Big Bang. And look, this isn't just a cool idea or a metaphor. According to Einstein's general relativity, this is literally baked into the geometry of our universe. Imagine a giant cone, but upside down. We're living on the wide, open part at the top right now. But if you trace any path of cause and effect, anything that has ever happened, backwards in time, they all slide down the sides of that cone and meet at that one single sharp point at the bottom. That's the beginning. And this is what's so mind-blowing about it. This isn't some abstract, far-off event. The actual atoms that make up your body, the air you're breathing right now, the screen you're looking at, all of it, every last bit, was once crushed into that single, unbelievably hot point. We are all fundamentally connected to that one moment. But, just like in any good detective story, when you start looking at the evidence really closely, you find a clue that just doesn't add up. There's a major contradiction here, something that almost breaks the whole case wide open. It's a thing called the horizon problem. So picture this. You look way, way out into the universe in one direction. Let's call that region A. Then you turn around and look in the complete opposite direction at region B. These two spots are so incredibly far apart that light itself hasn't had enough time in 13.8 billion years to travel from one to the other. They've never been in contact. They shouldn't know anything about each other. So here's the mystery. When we measure the leftover heat from the Big Bang, what we call the cosmic microwave background, we find that region A and region B have almost the exact same temperature. How? How is that even possible? If they've never been able to communicate, how did they agree to be the same temperature? It's like finding two people on opposite sides of the Earth who have never met but are somehow wearing the exact same ridiculously specific outfit. It just doesn't make sense. And we're not talking about kinda similar here. The temperature is the same to a precision of 1 part in 100,000. That level of perfect agreement across parts of the sky that are totally disconnected from each other, it's just statistically impossible. Something else has to be going on. So this puzzle was a massive headache for physicists for a long time. But it eventually led to one of the wildest, most amazing ideas in all of science, a solution called cosmic inflation. Okay, so here's the idea. Right after the Big Bang, the whole universe was microscopic, and everything was touching everything else. It was all mixed together and had the same temperature, like a perfectly stirred cup of coffee. Then, in a sliver of a second, the universe inflated. It expanded faster than the speed of light, growing from smaller than an atom to astronomically huge. Suddenly, those regions that were once neighbors were flung billions of light years apart. They can't talk to each other anymore, but they both remember being the same temperature from way back when they were connected. Problem solved. Now, inflation is a brilliant solution to the horizon problem, but it does something else too. It pushes our investigation right up to the ragged edge of an even bigger mystery, the Big Bang itself. The one moment our science still can't explain. See, if you run the math of general relativity all the way back, you hit a singularity. But a singularity isn't really a thing. It's more like a stop sign. It's the point where our equations just break and start spitting out nonsense answers like infinity. It's where the laws of physics as we currently understand them just stop working. And this quote just nails it. Most physicists don't think the universe actually started as a point of infinite density. No, they see that infinity as a big, flashing neon sign telling us your theory is broken here. It's a clue that to really understand the beginning, we need a deeper theory, probably something that unites gravity with quantum mechanics. So, we've followed the clues right to the limit of our own knowledge. The detective story has hit a wall, for now. So let's zoom out a bit and think about what this whole cosmic journey really means for us. Because this science, it forces us to ask some of the biggest questions imaginable. Was everything that would ever happen, you, me, all of history, somehow predetermined by that initial state? And the biggest question of all, why did any of this happen in the first place? As we get closer to the beginning, we start to blur the line between physics and philosophy.
So, if you're going to take just 3 things away from all this, let it be these. 1. Cosmology isn't just guesswork. It's a real science based on hard evidence. 2. The Big Bang singularity isn't necessarily the true beginning of reality. It's the beginning of our understanding. And 3. To solve the biggest mysteries of the cosmos, we have to understand the tiniest rules of the quantum world.
And maybe the most poetic part of this whole thing is this idea from Carl Sagan. The fact that we, a collection of atoms forged in stars, can piece together this incredible story is just amazing. In a very real way, we are the universe itself becoming self-aware. So this detective story, it's not finished. We're all a part of it. Which brings me to one last question for you. If you could ask the universe one single question about how it all works, and you were guaranteed to get the true answer, what would you ask? The question you pick might just tell you more about yourself than the answer ever could.